Hi guys, this is my attempt to explain the sections, the chapter 11, section 1. Section 1 is quite heavy because there's a lot of information that you are not familiar with. So there's a lot of vocabulary that you need to be familiar with. So we're going to continue look into how to describe a shape of your distribution so that you can choose more appropriate statistics. So statistics can be defined into two things. It can be a study of like data science, like what we are doing, statistics. But when we use the word statistic, it actually means all the numerical values that we use to describe the data. Okay, so mean is a statistic, median is a statistic, and so forth. Okay, so we have right now I wrote the measurements of center, which is mean, median, and mode. And below that is a measurement of a spread. So I think we talked about briefly to describe a distribution, we use center, spread, and shape, right? So we learned about center and shape. Shape, we use words like unimodal, symmetric, bimodal, things like that. And center, we looked into it a little bit, and we looked at how to find mean on the calculator and also median, and mode you have to count it yourself. And this is spread. So we're going to look into spread. So I'm going to pull up the same data statistic that we used for the class yesterday. So I told you mean is X bar, okay? And then I know there are a lot going on here, but basically what you're interested in is something called S of X. That's what standard deviation is. And that X is a little x, even though it looks the same. And standard deviation, it's a little bit hard to define exactly. And even if I define it, you might be like, what does that really mean? Think of it as kind of like how dispersed, how spread out your data is from the mean. That's what standard deviation is. So if you have a small standard deviation, that means all your values are pretty close together. And if you have a large standard deviation, that means your values are kind of far away, spread out from the mean. Okay, so everything is based off of mean. So when you describe your distribution using mean as a center, then you always have to choose standard deviation as your spread. Okay. Median, we talked about how to find median. Interquartile range is third quartile minus first quartile, and we've seen those numbers in our 1-bar stats. So we saw Q1 and Q3, right? So the first quartile is the first 25% of the data. So where does the 25th percentile falls in is basically the first quartile. Third quartile then is the 75th percentile, okay? So what does percentile mean? It means, so let's say I'm a 75th percentile. That means that below me, there are 75% of the population. So basically, I'm better than the 75% of the population. So if you remember PSAT, or if you've already taken SAT or ACT, you know that they always give you this like curve, what we call normal curve or bell curve. And then it tells you you're at a 90th percentile, right? That means that you're above 90% of the population who took this test. Okay, so higher the percentile is, or it will say like you're in the upper 1% or upper 5% kind of thing. That also means that you are above like 99% of the population or 95% of the population, and so forth. Okay, so Q3 is 75th percentile, and then Q1 is a 25th percentile, because quarter, right? So 25 comes from that. So when you choose median as your center, then you are going to choose interquartile range, which will be one value, okay? As an example, so here my Q3 was 88.5 and Q1 is 74.5. So that my interquartile range, or IQR, is 88.5 minus 74.5. So my IQR, interquartile range, is 14. Okay, you don't give me a range like a everyday language sense of range. In statistics, whenever we say range, it's a single value. Okay, and it's always so let's go to that mode and range. So mode and range is actually the least used statistic when we describe a distribution because it's kind of useless. Okay, because range, like I said, is we know how to find range. It's a maximum minus minimum, but because in statistics we don't ever say like let's use an example of our data. We don't say the range is 63 to 98, even though that might be very commonsensical in the other realm. Okay, in statistics, range is also a single value, just like the interquartile range. So your range in this case would be 98 minus 63, which is 35, and you will just say the range is 35. So if you think about it, if there is no other sentence to really describe what's happening with your data, 35 as a range is not very helpful, okay? But it's a very easy statistic to find, but nonetheless, it's quite meaningless. So you will always find people preferring mean and standard deviation as their way to describe the center and spread. But there is a disadvantage to mean and standard deviation. Like we saw in the skewed curve, the skewed distribution, so either skewed to the right or skewed to the left, mean follows the tail, meaning any extreme values can really give you, like it can misinform what the general population would be like. So then mean and standard deviation is always your first choice, unless there is a skewedness or something called an outlier. Okay, so we're going to talk a little bit more about outlier. So what term, the term that describes this phenomena, I guess, is something called resistant. So when we say resistant, it means that it's resistant to the extreme values or skewness. So median and interquartile range is resistant values, resistant statistics. Mean and standard deviation is non-resistant, meaning when there is an outlier or a skewness, it's not a very accurate description of your distribution. Okay, so if it's skewed, then you are going to always choose median and interquartile range to describe your distribution. If it's not skewed, and if there is no outlier, you're always going to choose mean and standard deviation to describe your distribution. Okay. So how do we find outliers? So today in class, we looked at the histogram. And histogram is great. It gives you a nice shape. You can see the shape of the thing, and then you can also see if there's a gap, like the example I'm drawing here, or if there's a cluster. Histogram shows you a good, it gives you a good idea of what the shape actually looks like in distribution. But even though you might be able to tell skewness and possibly an outlier, histogram is interval, right? That means that you can't really pinpoint a data point. So other type of visualization that we use for distribution, the data set, is box and whisker plot. And this one, your calculator also does it. Whisker or box plot. Sometimes we just call it box plot. And it looks like this. Okay, so if you've seen this, then you know what box and whisker plot looks like. So, and each of them does have meaning. So the very first point right here is your minimum. And my computer is not happy. And this part that starts the box is your Q1. The line in the middle of the box is Q2, or median. My computer, what is happening? Okay, sorry. And then the line that ends the box is Q3, so third quartile. And then the last point is your maximum. Those 5 numbers, you've seen them before, right? So your calculator, the 1-bar stat, another great thing about this is that it gives you the 5-number, what we call 5-number summary. And the 5-number summary is great to draw the box plot. And how do you graph the box plot? Well, we have to go back to our calculator and then go to stat plot. Instead of choosing the bars for histogram, we are going to choose so there are 2 box plots. Do you see? The one that has a dot dot at the end, and then the one that doesn't have a dot dot. Well, we are always going to choose the one with the dot dot, okay? Because the dot dot shows the outlier. So if you have an outlier in your data set, and if you choose the 5th one, the one without the outlier, the one without the dot dot at the end, your box plot will not show the outlier. But this one, this option will always show you the outlier. So this is what we're going to choose. And then we're going to do zoom line. And here is your box plot. And we can use the trace function to see minimum, Q1, Q2, which is a median, Q3, and maximum. Okay? So with this data set, there was no outlier. If there was an outlier, what you would see is a dot or a star sign there. Okay? So then how do we algebraically find outlier? So do you remember the IQR, which is Q3 minus Q1? We're going to use that. So to find outlier, you need your IQR, okay? And you are going to multiply by 1.5. And if you do Q1 minus 1.5, then you will have a value, right? And you will do Q3 plus 1.5 IQR, and you will have a value, right? We call this a lower fence, and then this one upper fence. So any data set, any data point that goes over those values are considered outlier. So it can be a very small value, or it can be a very big value, okay? And it really all depends on how spread out your data is, because IQR will be determined by that as well. It will be affected by that. So this is it for today's lesson. So a couple things that you need to remember. You need to remember which center measurement is matched up with the spread measurement, okay? You need to remember that the mean and standard deviation is non-resistant, so we only use it when there is no skewness or outlier. Meanwhile, median and interquartile range is resistant. That means you can use when it's skewed or when you have an outlier. But we do prefer mean and standard deviation. So if there's no skewness, use mean and standard deviation. Okay. You can use 1-bar stat to figure out the 5-number summary. But also your calculator does graph box and whisker plot for you. What else? And you can calculate the outlier using IQR. And outliers are important points that you do have to mention. So if there is an outlier in your data set, you will mention this data point and that data point was an outlier, which affects our mean and standard deviation and so forth. Okay? And that's it for today. I hope this helps. I know there are a lot more new words in this chapter than any other chapter. And I know you already graphed the number 1, 3, and 5 for yesterday's homework. I want you to go back to that graph and figure out whether you could have described it with mean and standard deviation, or you should have chosen median and interquartile range. And if there is an outlier, try to graph a box and whisker plot for all 3. And yeah, and see how it's different. What difference can you spot from your histogram versus your box and whisker plot? Okay, I'll see you on Thursday.